It's another Tuesday for W.Media listeners all over the world. Welcome to W.Media Podcast, where we bring and talk about all things AI and data center technology.
Here we have worldwide experts, leaders, and veterans who will impart in our panel discussions, their thoughts and expertise about the situations in the world today in this space.
I'm Kristelle Razon, the global conference producer for W.Media, and I'm very excited to introduce to all of you my dear guest host, Anthony Lim. I'm sure many of you are familiar with him. He is a pioneer of cybersecurity and governance in the region.
Thank you, Kristelle. Okay, we're delving into the fascination intersection of artificial intelligence, AI, and cloud computing, and we need to go hand in hand today. So get ready for an insightful exploration into the inevitable rise of AI adoption and its profound impact on the cloud. To introduce our speakers, we first have David Forden. We're very honored to have David Forden, Customer Engineering Lead for Google Cloud Indonesia.
Yeah, for sure. It's also my pleasure to introduce to everyone Jack McCauley, board trustee at the University of California, Berkeley, and former co-founder and engineer at Oculus View.
We have so much to learn from our guest speakers today, so I couldn't be more excited to start. But first of all, let's thank our sponsors.
This episode was brought to you by our supporters and sponsors at W.Media AI Supercloud and Cloud and Data Center Convention 2024, specifically Indonesia on May 16, 2024 at Shangri-La, Jakarta, as well as the Philippines on July 4 at Conrad, Manila, and of course, Thailand on November 14 at Centera Bradtac.
Let's start with the first part of this meeting. AI is transforming enterprise data practices by enabling more efficient data storage, consumption, and processing. So over to you, David. How is AI revolutionizing the way enterprises store, consume, and process data? And we'll hear from Jack later.
So looking at the revolution of AI and the way that enterprises is transforming and, in terms of consumption of data and processing of data, let's just touch on three dimensions. So the first one is around sort of intelligent data storage and essentially driven by AI. The second one is about really using AI techniques to enhance data consumption. Then the third dimension is around using AI to drive transformation and processing of data. So in that first dimension, so intelligent data storage, there's really three parts to that as well. So the first part is around tiered storage optimization. So when I say tiered storage, I mean, online, nearline, offline storage. So what AI enables you to do now is analyze the data patterns and automatically place the data in the appropriate storage tiers. So what this allows you to do is explore, the usage of, frequently used data, fast SSDs, and slower cloud or, historical archives of data, and maximize the performance of the solution while minimizing the costs. Then, predictive anomaly detection. So what that's about is looking at, monitoring storage systems, identifying failures or any sort of potential capacity issues before they cause outages or disruptions, thus enhancing the reliability, availability of systems. Then the third part of that is around things like deduplication and compression of data. So AI-powered techniques can be used to find and eliminate any redundant data and apply advanced compression techniques. So reduce the storage needs and, the bottom line there is save some costs. So around enhancing data consumption. So this is about fairly advanced techniques like, say, knowledge graphs. So what that allows organizations to do is build interconnected knowledge graphs that map relationships between the data from various different sources. And that provides a deeper understanding of the information and enables more sophisticated data insights. So there's many applications for this type of thing, especially in regard to things like customer data platform for various different industries. Then, natural language search is another good solid case around enhancing data consumption. So AI allows users to interact with databases and data warehouses using natural language queries. So the bottom line with that is that it reduces the reliance on technical expertise. It makes the data and the insights more accessible to users. It's very valuable for quickly ascertaining facts and insights from both structured and unstructured data. Then there's kind of data discovery. So what that is about AI-empowered tools that enable you to automatically analyze vast data sets. You can surface trends, you can surface patterns, you can surface correlations, which would normally be pretty much inhuman. So impossible for humans to navigate due to the size and complexity of data sets. And then if you look at, AI-driven data transformation and processing, that third dimension, the first part of that is really about cleansing and data prep. So you've got the ability to automate a lot of tasks around the sort of tedium of identifying and correcting errors and filling in missing values and formatting data and so on. Then the second part of that is about feature engineering. So it helps you to select, transform the most relevant data features to improve machine learning and model performance. Then really the last part of that is around ETL automation and real-time analytics. So what that allows you to do is get a seamless streaming experience with ETL and enables faster, more adaptable data pipelines, which leads you to a much more capable real-time analytics system. And again, using AI to power those real-time analytics and insights is another pretty important aspect. And there's many potential benefits across industries. So, it helps with improved decision-making. It helps with more efficiency in process automation and enhancing an organization's agility. Everyone wants to go to market with solutions faster and innovation with new products. So you could look at some use cases around, let's say in banks, things like fraud detection, predictive maintenance for large manufacturers and some of those types of organizations, and just about anyone for things like personalized one-to-one marketing. So I hope that gives a little bit of insight as to how some of that transformation is going on. Over to you again, Anthony.
Thank you, David. Well, there's quite a bit of insight and, quite eye-opening. There's a lot behind the scenes, and I hope we will want to Jack now for his insights to add on top of yours. Thank you.
Here is the number one issue with AI. It comes down to dollars and pounds or euros, whatever you want to take. Is that the cost to purchase enough GPUs or TPUs, tensor processor units, that's the engine that runs AI, is prohibitively high. And you need thousands of them in parallel. And furthermore, they're not going to be busy all the time. The duty cycle, which is the amount of time they're actually functioning, operating, might be fairly low, 30%, something like that. So it's a resource, an expensive resource that sits there with 30% utilization. Not always, but so to the question of how is it revolutionizing, it's much better to buy the artificial intelligence generative AI as a service and pay a subscription, which is precisely the model that Microsoft has for Azure, which is their supercomputer. So this is the issue. A good GPU, let's give you an example. The NVIDIA Titan 5 GPU, which does 160 trillion floating operations per second. It's so fast. Is $2,500. You multiply that times 1,000, and you're looking at $2.5 million or $3-4 million because of with hardware, with a utilization of 30%. So this is why it makes sense to do your GPU and TPU processing and AI in the cloud. Simply because it's cheaper. If you're a startup company and you want to be a competitive AI startup company, you're not going to buy a supercomputer with 1,000 GPUs in it. You're going to get a service. ChatGPT runs, its backbone is Azure One supercomputer service by Microsoft. So this is the core business model. It makes a lot of sense too. Much in the same way that if you had a lot of storage, right? You need to store a lot of data. You're not going to put a rack of hard drives in your office. You're going to use a service and pay a subscription fee. It lowers your cost and your barrier to entry. So this is how a lease model where you lease the service, the GPU service, makes a lot of sense. If I were doing a startup company now, I wouldn't try to build a supercomputer or a rack of GPUs. I would buy it, the service, and use that and build my software on that, top that API.
Moving on, I want to know for David and Zach also, like, what kind of machine learning algorithms and frameworks do you see enterprises adopting predominantly for their AI initiatives? Yeah, maybe we could start with David.
Okay, sure. So this is an interesting question. I mean, at my age, I've had a hip implant that helps me walk, but I'm wondering whether I actually need a brain implant to help me with dealing with some of the things that are kind of moving in AI. And it's very difficult to sort of keep track of that. I'll talk about that a little bit more. So essentially, enterprises need to adopt AI and ML without the complexity that it brings. I mean, Jack may have a different inflection on this, but I feel that adoption is more a question of frameworks rather than algorithms for ML. And it needs to be this way in order to democratize AI. When I say democratize it, I mean make it available to humans, to people who are not, data science or ML engineers, people that essentially are users in the context of where we need to be with AI for business. So the algorithms themselves, they're quintessentially just too complex for regular folks to really comprehend. They kind of fall into three broad categories. So the supervised learning category, the unsupervised learning category, and then the deep learning category. So this is really the domain of data science people and ML engineers, to be frank, right? So AI frameworks, by definition, they mask the complexity and the nuances of these algorithms. So essentially what they do is abstract these algorithms into higher level APIs for use by citizens and developers without that detailed, comprehensive need for data science and ML engineering knowledge. And in this scenario, the implementations of the algorithms, they're largely hidden from view. So in my opinion, and this is a little bit kind of biased, I guess, given the fact that I work for Google, but Google provides an excellent way of doing this through a solution called Vertex AI. It's a framework that essentially is a very classic example of democratization of AI and ML. It allows businesses without those really expert resources to get on with the job with AI and ML. The focus on that framework, on Vertex AI, is simplifying AI and ML ops being the DevOps of ML for enterprises. And essentially, the way that fits as an ML ops platform, it provides a suite of tools and services that addresses the various stages of the machine learning workflow. So the first phase is around data preparation and feature engineering. So features like systems like Vertex AI or frameworks like Vertex AI provide like a feature store that streamlines feature management and data preparation. Then secondly, model development. So what it allows you to do is track experiments. It gives you a model registry and a bunch of other tools to make model development more systematic and more traceable. Then, Vertex AI also offers hundreds of both first-party and LLM and third-party LLMs, like the various different incarnations of Gemini, Imagen, Palm, etc., which are first-party from Google, and then third-party models like Llama 2, Claude 3, and others. So these are all available for integration so long as they comply with the means and works of TensorFlow and PyTorch, which are the frameworks that are embedded into Vertex AI. Then comes things like training and tuning. So Vertex AI actually simplifies the process of training models at scale, and it gives you options for either custom training or using systems like AutoML, which is much more citizen available or democratized, if you like. Then on top of that's deployment. So Vertex AI allows you to deploy models easily into various different environments. So online or batch prediction type endpoints, all sorts of capabilities there. Then, monitoring and retraining, which is also very important with ML. When you think about machine learning, it's like having a little kid. It starts at a certain point in life, and then you need to sometimes keep learning and keep training. And people are like that too. We're all the same. We grow, we learn, and ML is no different to that. So Vertex AI pipelines help to automate the entire process of ML and do that while integrating and monitoring defects and performance and hallucinations and any drifts in data or changes that might necessitate updates in the model. So there's some popular frameworks around that are of note. I don't want to get into too many details of these, but the kind of heavyweight champions in this area are TensorFlow and PyTorch. There's others around like scikit-learn, MLflow. Keras is another one that's now embedded in TensorFlow. And then LangChain I thought I'd mention, because LangChain is kind of more on the programming side, but what it allows you to do is get a standardized interface for interacting with various different LLMs. So it handles the complexity and the details of all the APIs that are associated with those LLMs and eliminates the need to learn a whole bunch of different APIs for the different LLMs. Helps to streamline development. So I hope that kind of adds a little bit of an inflection on, what kind of matters in terms of frameworks and algorithms. And what I'd urge everyone to sort of do in this space is try and remain sane. Take the steps that are going to keep you sane.
I'll talk about my area only. It's so diverse, and I don't have, with a few exceptions, have a good clue about what everyone is doing. But let me tell you about autonomous driving and how AI can help that. So, an autonomous vehicle has to use a feature map of the road and then integrate the feature map of the road, like how the road is curved, whether there's an object in the road, has to integrate that with real-time data. And those are usually done with a vision system. Some radar, they have a little radar array on the front of the car to tell them if there's an object approaching them or where it is. So a combination of things. But I think the backbone of autonomous vehicle success will be an AI-based one. Being able to interpret safety objects, it doesn't work that way right now. It's just standard coding, if you will, with SLAM. And SLAM is simultaneous localization and mapping. And the map for this, say you've never driven down this road before, you're let's say in Ohio or something, and you've never driven on this road, so your autonomous vehicle does not know the road. But some other cars might. Other autonomous vehicles that are hooked to a radio, like a cellular radio, do know that road. They've mapped it for you already. So what SLAM does is apply that map to your vehicle. So it knows the surface and the road, and then it integrates those with the sensor system on the vehicle. So AI could certainly help. And in the case of EVs, this is another area where AI is useful. It is determining the state of state of charge of the battery, trying to determine what temperature it is. The state of charge of the battery on an EV is proportional to temperature, actually. If the battery gets very warm, it likes it, like room temperature, 80 degrees Fahrenheit. If it's cold, it does not like it. Trying to adjust the battery usage and mileage for, let's say, a trip based on the knowledge base of the battery and the battery condition, the life, and so forth. Also, the control of the vehicle in itself, like if a driver gets in and it detects the driver's state, mood or whatever, and changes the interior lighting and so forth to match, to make the driver feel better. That's a great idea. I think I just came up with that. So this is the how AI can help with the autonomous driving and in vehicles in particular.
Okay, now speaking of AI and ML frameworks, back to you, David. What are key decision drivers for enterprises to choose these frameworks, and how do these choices impact the business processes and outcomes?
Yeah, sure. Great question, Anthony. And obviously that's on the lips of everyone in enterprises these days. It's one of those things that it happens with every generation of different technologies that have to evolve and get adopted and integrated into the enterprise. So, AI technology, it's evolving to meet consumer needs, right? So like all other technologies, historically, AI and ML are evolving to meet those needs. And essentially, both the sort of, the consumer segment and the enterprise segment involve regular humans. It involves human beings, right?
Right.
And, dealing with complexity, it takes time, it takes money, and it also increases business risk. So these are important things to consider. Essentially, what this means is there needs to be an initiative to simplify interfaces, really shorten the learning curve, and, embrace frameworks that offer the ability to, develop things rapidly and then deploy them in a a safe, secure enterprise environment that can facilitate adoption at scale. So, enterprises, they really need to respond fast to market needs. So the market conditions are things that need to be responded to in a very timely manner. It's the same for every single industry now. Industries are becoming hyper-competitive. What this means is rapid development, rapid deployment, rapid tuning are things that need to be a part of the framework for deploying AI. So again, Vertex AI achieves this and very nicely, and it really delivers a very democratized AI framework that a lot of enterprises need in order to be productive and do things inexpensively to really cross that AI chasm. And I've mentioned sanity a couple of times. This is something that I think is plaguing everybody in the industry, right? So trying to keep up with the technology details in the AI space involves kind of jumping into like a fast-moving time vortex. And getting up to speed is a very big challenge right now. Staying at speed also requires a ridiculous amount of time and effort. So my opinion is that the details on this are probably best delegated to the specialists that live in cloud vendors and live in product vendors, and really organizations should be seeking to leverage the frameworks unless you're really attracted to the prospect of developing what I call techno insanity. That's kind of characterized by, technical addiction, knowledge anxiety, and, death scrolling and this type of behavior. So I guess that's a reasonable inflection from my perspective on where to look for the value.
Yeah, you're right. Basically, so these frameworks help with the time to market, and time to market today is money. But at the same time, you need to remain on a sanity level while you're going through that. Thank you, David.
Also, I want to know, just moving on with this, what are the primary cybersecurity risks associated with migrating sensitive AI workloads and data to the cloud? And how can enterprises mitigate this risk efficiently? So we have here Jack also.
Well, I spent a good, I would say close to a year working in cybersecurity on and off. It's other things I work on too, but I spent a good deal of time because I really didn't know anything about it. What does cybersecurity mean, right? And my discovery was that the passwords that people choose to their bank accounts, for brokerage accounts, for other aspect Wi-Fi passwords were terribly simple and often based around the family relations. Like the person has a child and it names the password the child's name. So AI could actually go in and try to figure out, based on the profile of this person, how they would name their passwords. And here's another one we discovered. And this is WPA2 on Wi-Fi, which is the least secure method in Wi-Fi of securing it, right? So is that we could remotely disable the access point for that user with a command, which is part of Wi-Fi. And then what they do is they go to try to log back in and they enter their password. Now you have their password. You log into their Wi-Fi remotely, see if the password works, and you probably have their bank account password. So don't have a different password for everything. I can't tell you exactly where I keep my passwords, but I keep them. And I make sure that I have a little bit of a difference between the passwords, although it's easier to remember just one password. So password hacking and offensive cyber intrusions and so forth is a good avenue for AI.
All right, that's true, Jack. Now, before we continue with the segment, let's thank our sponsors at the AI Supercloud Conventions for Indonesia, Thailand, and the Philippines again. This event officially partnered with W.Media will have over 1,000 participants. It is the hub for cutting-edge exploration for artificial intelligence or AI, fortified cybersecurity, and the dynamic power of cloud technology. So, immerse ourselves in forward-thinking insights, engage with industry leaders, and navigate the strategic intersection of technology and business school. For more information, you can visit AISupercloud.events and clouddatacenter.events. Moving forward for our next segment on what to explore scalability and performance challenges.
Okay, we'll start with Jack. Okay, in this segment, 2 about scalability and performance challenges. So we're excited to explore more and know more speakers' views on these areas. So Jack, what when comparing the cost efficiency of owning dedicated servers versus scaling AI workloads on the cloud, what are the key factors that enterprises should consider for TCO, total cost of ownership, performance, and scalability?
Well, I'll work from example, and I'll explain what I would do. Being a tech guy myself and entrepreneur with a couple of large exits. Here's the thing: when you're a startup company and you're trying to attract investors, you want to attract investors. Most investors are not going to invest in a hardware-based company. I know of a person who left the company I used to work for, Meta, actually, after they got acquired. This person immediately did a startup which is hardware-based, and I'm going to myself, I go, he's going to struggle with that. It's very expensive, and the risk to investors is very high. So here's my point. I would use a cloud-based, scalable AI service rather than trying to build my own AI system. Unless that's your company, you're going to build the best AI system. That's a little different. But if you're building an AI service that people will use, you just get cloud space. I'm willing to bet that the utilization rate for people who do build their own AI systems, including GPUs, TPUs, and so forth, is 30% or less. It's probably less than that it's being used. So just use a cloud service. There are concerns about security. I understand these issues. There are means to encrypt things which are nearly impossible to break. So there's ways to do this without having to purchase large enterprises and servers and so forth, put them in your building, and AI banks of GPUs and TPUs. I would go to a service. As a matter of fact, if you approached me, I wouldn't invest in a company like that. I just think it's too problematic and too risky and too expensive. It's much better to leverage less money on a software company and invest in a software company than it is to leverage a lot of money and risk a lot of money on a hardware company. This is the problem we had at Oculus, precisely. And other places I work, I'm a hardware guy, so it's very, very tough to do this. I got approached by someone just a week ago who has a hardware startup. It's a young person, nice young person. But I told her straight out, I said, look, you're going to have a tough time finding investors. It's just really, really hard. They don't want to take the risk, the capital risk, so forth, and the product may not work in the public domain. So back to the question, I think it's better just to use services. That's what exactly. As a matter of fact, if you came to me and you said, I want to use a service, I'd say, great. Which one are you going to use? We're going to use Microsoft's Azure one, supercomputer, whatever. Perfect. Then you can focus on software. That's what I would do. Thanks.
Yeah, for sure. And also, I think that enterprises must also strike a balance between customization and convenience, considering all the factors that Jack mentioned. But for our next questions, I want to know for David and Jack also, what strategies and best practices can enterprise employ to ensure that optimal performance and scalability when deploying AI solutions in cloud environments, especially when utilizing GPU accelerated instances? Maybe we could start with David.
Wow, Kristelle, I think you're developing a reputation for asking really hard questions. Because I'm kind of looking for that brain implant right now to kind of help me a little with this, but I'll give him a best shot. No?
Right, it's getting complicated.
Yeah.
So, yeah, when you go about the process of deploying AI solutions on cloud environments with GPU or even TPU accelerated instances, you require specific strategies to really ensure the performance and the scalability. So I'll try and kind of break that down into a few different areas. So first thing that comes to mind for me is architecture and infrastructure design, which I think is pretty important for this because it's very infrastructure and architecture oriented in its basic aspect. If you're talking about reliability, scalability, performance, and doing that optimally at an economic sort of cost, right? So the first thing around that area is choosing the right GPU or even TPU instances. I don't know whether everyone's familiar with TPUs. GPUs are tensor processing units. That's a Google offering. It's kind of similar to GPUs, but there's additional kind of different ways of sort of doing the matrix manipulation, matrix multiplication, this sort of thing with numbers, particularly with floating point numbers. But I don't want to digress into all the details around that. So essentially, choosing the right GPU instances, it enables you to ensure that the workloads are appropriately mapped to instance types, based on the memory, based on the processing power that's required, and based on the network throughput. So there's a lot of cost performance trade-off in that area. Probably the second area, which is very kind of topical when it comes down to model training. Model training can get really expensive. So when you look at, say, distributed training, there's a bunch of frameworks available for that. So for very large models with extensive data sets, you've got to leverage distributed training frameworks like Horovod is one of them, TensorFlow Distributors is another. And libraries like PyTorch Lightning can help you to train across multiple GPU instances or TPU instances. Then, network optimization. So kind of pivotal to ensure that you've got sufficient bandwidth and low latency between the GPU instances that you're running, and make damn sure that there's a solid distributed training framework in place. And particularly if there's a significant data transfer going on, which is often the case. So in those situations, actually, you can incur a lot of egress costs on the network. So that's something to also consider. Then there's hybrid cloud considerations, so certain workloads, hybrid approach, so combining on-prem and cloud GPU resources and so on, perhaps with cloud bursting, could actually be the most cost-effective way to do it. So that also allows you to leverage, cloud when you've got, say, peak demand going on. Then the second thing that comes to mind, is workload optimization. So every workload that you're going to deploy has its own unique characteristics. So there's obviously techniques you can employ to maximize your advantage. Perhaps using, say, lower precision floating point formats like FP16. So basically, or even FP8. So these are basically lower precision numbers than the usual sort of 32-bit floating point numbers. So this can significantly accelerate training times. It can help to do things without, really significantly sacrificing accuracy when it comes down to 16-bit. So there's a lot of, value in optimized libraries that you can enjoy around this. So some examples there, GPU accelerated libraries like CUDNN, CUBLAS, TensorRT is another one. These are specifically designed to optimize for NVIDIA GPUs. Then there's libraries like TF-Keras for Google's TPUs. So these leverage hardware capabilities in a more efficient way than the generic libraries do. Then, data loading, pre-processing. So that's all about optimizing the data pipeline and preventing bottlenecks, making sure that, data is fed into the GPUs in an efficient way, pre-processing the data on CPUs to reduce the costs. So that ensures that, maybe you can utilize asynchronous type loading using messaging frameworks or what have you to ensure that the load on the GPU during a certain period keeps it fully utilized, and that lowers the total processing time. It really depends on the goals that you're seeking in terms of that. So obviously there always needs to be a balance between time and cost, right? That's kind of what cloud computing is all about, at least, right? So when cost management, resource allocation, and so on come into the picture, there's a need for cost tracking, budgeting. So I'd suggest that people look at implementing, granular cost monitoring for GPUs and all the associated resources. So set the budget, set the alerts, and try and prevent any runaway expenses. Then, right sizing. So, periodically you need to assess if instance sizes are matching the current workload demands, and look at right sizing your instances, optimizing the memory and CPU and GPU footprints, and prevent overspending. Then there's also capabilities in most cloud providers for what we call spot or preemptible instances. So this allows you to, look at non-critical workloads and save costs, and at the same time sort of, design fault tolerance. And then obviously serverless computing, auto scaling. So these are things that also help you to, really assess the need and demand for GPUs and try and maximize the resource usage and the performance without kind of exceeding the FinOps barriers, right? A couple of other things that kind of bear mention. Firstly, containerized environments. So, Docker, Kubernetes, and, packaging apps and deploying them that way allows for a lot of flexibility. Obviously, being from Google, I'm going to recommend GKE for that. Obviously, you can deploy third-party solutions like OpenShift or whatever on Google Cloud. There's not a problem with that at all. And then, looking at model optimization for inferences, that's another area that's interesting. So reducing the size and the computational demands of models, specifically for the deployment aspect. So looking at quantization and pruning techniques. So what that means is being able to leverage some of that floating point capability I was talking about earlier to compress the footprint of the models and optimize them for different deployment scenarios. So that's kind of coupled with maybe performance profiling as well. So if you look at some of your Python code, you can kind of identify performance critical sections and optimize them for both GPU, TPU, depending on what you're using. And that may reveal certain code patterns that you need to refactor or redesign. And then logging and alerting. So having a comprehensive system for logging errors, logging warnings, logging performance metrics, and establishing that framework and having the feedback into your DevOps cycle, your MLOps cycle, is critically important. So that to me is the kind of, in a nutshell, the areas that I feel are really relevant to the question. Thank you.
Thank you, David. That's a lot of details in a nutshell. I don't know how you said all that in one breath. Yes, so David, earlier on you alluded to about hybrid cloud solutions, and which offer enterprises flexibility to leverage on-prem resources while benefiting from scalability for the AI workload. So the question is, how do hybrid cloud solutions play a role in balancing on-prem resources with cloud scalability for AI workloads? And what challenges might arise in managing such a hybrid infrastructure?
Oh, cool question, Anthony. Maybe I opened my mouth a bit too wide there. Now I've got to go back to the implant and kind of work through that one. But right, well, just off the cuff, I think, hybrid cloud solutions really, they do play a crucial role in balancing your on-prem resources with the sort of massive scalability and massive abilities that are available there in cloud, or the more or less limitless scalability you can achieve with cloud. So that, I think, is particularly relevant to very demanding AI workloads. And I think there's a way in which you can achieve this balance. And, there are also, at the same time, there's also some potential challenges, right? So, nothing's perfect. Let's talk about some of the things that we can do and some of the challenges and imperfections that we need to deal with. So, firstly, organizations that make investments in on-premise infrastructure, they want to leverage those investments and they don't want to abandon them when they need to use cloud resources or they're sort of driven in that direction. So that's where hybrid cloud kind of allows that gradual migration and allows them to maximize the value of assets right up to the end of the asset life cycle when they're doing things on premise. And, once the assets sort of reach that life cycle juncture, they've got, hopefully, if they take notice of what I was saying about logging and understanding all the performance metrics and measuring the costs and so on, and they do a good job on understanding the total cost of ownership, they can make better decisions on, how they want to replace those resources later, i.e. whether the workload's better off running on cloud or whether it's better off running on-prem or even multi-hybrid cloud if you want to go down that path, right? There's an era coming now where I think most large enterprises are starting to move down that multi-hybrid cloud path. And a lot of the lessons around vendor lock-in were kind of learned in the 1990s, right? And that's how standards evolved. That's how open standards, which were sort of driven into the market, much to the ire of vendors. Vendors didn't really want to go there. Mm-hmm. The customers kind of forced us to in that respect. And I think multi-hybrid cloud is kind of driving in that direction too now. And the biggest risk for customers in that scenario is exactly the same risk as it was back in the 1990s, right? So it's kind of Back to the Future if you've ever seen that movie or that series of movies. Yes. The interesting part about this, I think it gets down to, firstly, specific placement of workloads. So if you look at the different phases of the AI life cycle, they have different and unique needs. So the training phase often requires really massive compute and massive GPU or TPU resources. So the elasticity and the scalability you can get in cloud is really ideal for this. So I'd urge people, if they're doing large training jobs, don't even consider running them on-prem. use cloud that by default and save your on-prem resources for the things that have the most bang for bucks. And in fact, at the end of the day, if you look at trying to fund an initiative to train models on-prem, you're probably going to run out of money.
Mm-hmm.
That's part of the lesson that I think people don't want to learn there, right?
Yeah. And also a big database for training.
Sorry, again?
A big database for the initial training.
Yeah, so that's the other thing is data, right? I mean, you're talking about massive amounts of data associated with training, which implies you're going to need to have the data transferred into the cloud. You're going to need to probably cope with the egress costs there. And when you look at the total cost balance there, there's a curve, right?
Right.
So beyond that, I think inference is another area that's kind of interesting. So once you deploy a model, you've got to serve the predictions, and that might be handled better by on-premise, depending on what you're trying to do. So there's a few reasons for that. Some of it's around things like lower latency. Data security is another one. And that really is principally dependent on what each customer wants to do, what the data sovereignty regulations they have are in place. That all being said, in Indonesia, we actually have a region in country, so that data sovereignty is not so much of an issue for us. But other countries could face those sorts of challenges with cloud providers, right? Then there's like the sovereignty and compliance thing, like I said. So there could be sensitivity around data. Needs to remain on-prem. You've got to adhere to strict regulations, and at the same time utilize cloud for maybe the less stringent needs. But there's a lot of decisions to be kind of made around that hybrid workload, hybrid cloud workload balance, right? And then cost optimization. So like I mentioned earlier, around things like bursting into the cloud during peak training demands, and avoiding over provisioning of expensive hardware on premise, which I think it should be something that it's going to sit idle all the time if you buy that stuff. And that's one of the things that cloud vendors have made their money out of historically, right? Is being able to optimize what people are doing from the on-prem environment. So unfortunately, a lot of customers don't really go into a lot of detail with their cost of ownership. That's really sad in a lot of ways, because it helps. If you have that in place, it helps you to really see the value of cloud. And I know there's this kind of notional 30% cost saving or whatever that vendors say in terms of using cloud, but if you track those costs across the on-prem and the cloud environments in a lot of detail, you'll be able to realize those cost savings. And I think that's a pretty important thing to do if you're looking at embarking on a hybrid cloud initiative. Then, managing hybrid cloud. So that's when the complexity comes. And it gets even worse with multi-hybrid cloud. So when you look at things like, just literally the complexity of resources across those environments, it's going to get much, much worse compared to a single platform. So there's a lot of things that you can do in that area to help move the needle. So one of them that comes to mind immediately for me is everything as code. So I don't know how familiar you all are with that, but like, for example, I'm not plugging any particular technology here, but there's multiple ways to kind of go about this. One that comes to mind immediately is using something like Terraform from HashiCorp. So that's something that allows you to build a provisioning scripting framework, or templates, if you like, to provision resources across different environments efficiently, quickly, do a quick FinOps job, optimize, understand where the workload's best deployed, and then change the platform if you need to. So it allows you to, change platforms and workloads very readily, and pretty much in step with what you're doing consumption-wise, help you to optimize costs. Then there's that kind of issue around consistency, interoperability. So the idea there is that, you need to ensure that the tools, the models, the data, everything works seamlessly across those environments. That's a huge challenge, and that involves standardization. So you've got to really put a lot of effort into ensuring that things like compatibility, orchestration, all of the architecture, the APIs, the way that these solutions are tied together is addressed in a consistent, interoperable manner across those environments. Again, very challenging, particularly environments like telco, where they have to integrate back to their billing system and so on if they're doing like a B2B type scenario. So lots of things can kind of impinge on that. And then, network and data transfers, which I mentioned earlier. So you've got to look at really understanding what's happening with connectivity between on-prem, cloud, multi-cloud, especially with large data sets and volumes for model training. The egress costs can very quickly become a large finance issue. Then security. So having a consistent security policy framework, something that's sort of built around the ilk of a NIST CSF. Those sorts of standards kind of are a guideline that, every customer needs to build a framework that helps them to, get closer to compliance with that. And security is one of those things that's, it's unattainable. 100% security is unattainable. It's not a possibility. So, having a framework in place that gets you closer to bridging that security gap and getting you much closer to a sort of, I guess you'd call it a penultimate implementation of what this recommends with CSF is a great thing. Then it also comes down to the skills gap. So if you look at, managing hybrid multi-cloud, there's complexity involved in that, and the teams are going to be challenged to deal with that complexity. So skills, expertise, the data center management capabilities. A lot of people have built their careers around traditional data center management, and just transitioning to one cloud is a challenge. Or, to me, I sort of see there's a couple of strategies for success, and I'll try and summarize on this, but really unifying the management tools is critical, right? Second thing is, again, containerization. So ensuring you leverage replatforming around Kubernetes, because that's going to give you the ability to manage a lot of solutions at scale without too much interjection from the operations team. Very strong governance. So having all the policies in place to handle all the resource allocation, security, that's essential to maintain control over a hybrid setup. Then automation. So making sure you've got automation in place for all of those nitty gritty DevOps, DevSecOps, CI/CD, MLOps tasks, right? Yes. In kind of envision, there's a lot of value for this for different industries. So that a lot of them come to mind. So, telco, financial services, healthcare, manufacturing. The manufacturing, for example, predictive maintenance is a big thing in manufacturing, right? So having models trained in the cloud but deployed on-prem in a near factory environment is pretty important for them. And then it's need, because they got the need for real-time analysis on the factory floor, right? Right. All the equipment and instruments and all the instrumentation, all the PLCs and messages coming off the networks and so on. These are things that need to be analyzed in real time. So I think, to me, that kind of in a nutshell sort of navigates some of the complexity with multi-hybrid cloud. Yeah. Right. By seeing the importance of all that. Yes, over to you, Kristelle.
I want to know for Jack. This question is for Jack. So migrating data to the cloud is cheap. Accessing and bringing data back to premises where AI use is expensive. So hence processing at edge is preferred because it is more affordable. So what is your view on this, Jack?
So here. Let me give you another example. Let's say you're a country, and you're a country that is going to be using AI as a defensively, is defending yourself, like preventing enemies and so forth, and intruding. You would not use a cloud service. You would bring this internally, and so I think it depends on the application. If I'm the Department of Defense in the United States, or M5 or whatever, there's in Great Britain, I would bring the service internally. They certainly have the money to purchase large banks of AI stuff and personnel to run it. So this just depends upon your application. Now, if you're a commercial application and you're not as concerned about security, I am concerned about security. I don't like my data on the cloud. I don't like it because I don't know what they're doing with it. Is it used for nefarious purposes? Someone trying to find out where I'm living? This is the issue. So I think we need to weigh which application it is in terms of whether it's a government agency or an NGO or what have you. Here's a great thing. I talked to Rick Smith from the company that makes the taser. This is about a year and a half ago, right? So I built this thing for defense. Two things. One is for shooting down these drones, and the other was for crowd control, right? Like acoustically controlling a crowd, like blasting was high volume sound. And what he said to me was, you can't use weapons and stuff like that harm people in regards to the acoustic thing, right? And I'm going, but you make the taser. And he says, yeah, but we have 8 attorneys working for us that handle lawsuits. And it turns out that their revenue, that the company that makes the taser, Rick Smith's revenue, is cloud services for police officers who have this wearable cameras, right? And we're going, that's brilliant. I mean, he transitioned away from hardware into software and has monetized it. So their revenue is coming from their cloud services. Excellent. Very smart guy too. He's very down to earth. I was impressed with him. And an entrepreneur. I certainly wouldn't have gotten into the business of making a taser. I think that's too risky. If people fall down and hit their head and get tased accident, whatever. Just seeing that, and he realized that and transitioned away to a software company. And they sell the cameras and stuff, but that's really not where the revenue is. It's coming from cloud services for the cameras. I mean, if you're out in a place where there's no cellular service, it's over the cellular phone. There's no cellular service that it's going to record internally. Then when you go back into the office with police office headquarters, it downloads the stuff to cloud. And so this is my point here is that for that kind of application, where it's risky to put stuff in the cloud, it has to be weighed as to what you're trying to do. And for me, if I'm running a defense establishment, a government agency, I want my own stuff. I don't want to put it out on the cloud or even on the internet, really, if I can avoid it. So you do that internally. Commercial business, you use services. I don't know if Rick knows what service he uses or even has one. They probably bought it. That's what I would do. And I don't know.
Okay, we've heard from the expert gentlemen on AI, on workload optimization, on frameworks. Right now, we move down to the heart of the system, which is the chips. So in segment 3, we're going to talk a bit about the dynamics of the chip market and technology leadership. So, okay, back to you, Jack. We'll start with you. The chip market is experiencing significant disruption with emerging competitors and innovations challenging NVIDIA's dominance. Okay, considering the evolution of the chip market with NVIDIA often seen as a dominant player, and have you bought the shares? How do you see the landscape changing? How do you see the landscape changing with emerging competitors and innovations, Jack?
I do know some things about Jensen and NVIDIA. Oculus, I'm the co-founder of Oculus. We tuned our LCD displays at NVIDIA. They tuned them for us. We didn't have the resources to do it. We didn't have the engineering horsepower. We didn't have the cameras that are required. I do know those guys. What's amazing is the size of the campus that's there now. It's over on Central in Santa Clara, California. It's giant now. And when I was there, we're working on that camera tuning stuff that 10 years ago wasn't that big of a company. Didn't look very big to me. I mean, it looked like a modest company, but now it's huge. And we're huge because of the revenue that's coming in off their GPUs and their chip sales. I mean, those GPUs, they've cornered the market on that. And they've been at it since 1993. Jensen, other people founded that company, and it was for computer graphic, right? So turns out that the GPU, graphic processing unit, is called a GPU, and the tensor processing unit for AI are roughly similar. And so it was a good fit for them. They just kind of, in 1999, they came out with their first GPU. This is for I'm a video game guy, right? So came out with the first GPU, revolutionary, sits in a PC. It's a PC gaming GPU. There are others that tried in AMD and so forth, that stuff. But NVIDIA's far, far ahead, and they're a fabulous company. In other words, they don't have their own production facility at all. They don't produce chips. What they do is they use a service, which is smart. Their service is Taiwan Semiconductor Manufacturing Corporation, TSMC, who's now moving to the U.S. And TSMC is so far ahead in their processes, their density of layers of transistors and so forth they can put on chips very ahead of everyone else. With the higher density also comes lower cost. And so the margins improve, your money flow improves because your chip silicon is smaller, right? So they're using TSMC, and that's a smart thing. I don't know. Jensen's from Taiwan. Originally, he's an American guy, but and his family and stuff has ties to Taiwan. So I think it's because just a confluence of things. What took off for NVIDIA was computer games. That was a big hook. And the GPUs that were sold on PC-based games and so forth, that's how they won. And It just so happens that AI uses the same stuff that kind of fell into that spot. I'm sure they knew about it. I mean, of course they did. They had no idea that it would be so prevalent now and with so much investment and so forth. So I think it has to do with their video game business taking off from 1999, 25 years ago. They came out of their first GPU and they've evolved since then. And now they're an AI provider, chipset provider, chips really, but the whole package provider for AI. The Titan 5, let me give you a reference, right? The Titan 5, it's 116, I think it's 160 teraflop, trillion floating point operations per second, unheard of, right? And in 99, it was 670,000, in 1989, it was 670,000 floating point operations per second. That's how far they come. I'm not saying in 89 they had GPUs, they didn't, but they had these things called a math coprocessor. So that's just unheard of. A Titan 5 running that fast. It's just unbelievable. So I think what's interesting is that how the affected video games have had on AI. It really is. They're interrelated, even though video games don't use artificial intelligence. They are related, and that's because of the graphic processing unit and the fact that GPU does the same sort of math operations called linear algebra that is used in AI.
We also want to hear your thoughts on this, Jack and David. You could start with we can start with anyone's. What are the potential risks for enterprises in heavily investing in one technology or vendor? How can they diversify their tech stack to mitigate these risks?
Let me, before I answer that question, explain why one company in particular, Jensen's company, NVIDIA, is so far ahead. And this has to do with when they started. They started in 1993. Really, that's when the company was founded. And in 6 years, they had a full functioning GPU, it was basically a math engine for doing computer graphics, right? And so they're way ahead, and they're using a fab. They're a fabless company. It means they don't have a production line or anything like that. They just send their electronic files to a company, and they produce the part for them. So NVIDIA has really dominated, and they're so far ahead. Now, there are other people, other companies with a lot of capital that can invest. You need competitors. If you don't have competitors, you get lazy and you get happy with where you are. So you need competitors. And so I see on the horizon, possibly in China or another place. China should probably, if they're smart, would invest in GPU technology. Another player coming out, right? That's going to challenge them. The Qualcomm Snapdragon chipset has a GPU in it, and it's pretty good. It's used for VR. It's actually really good. Your phone has a GPU, your modern phone. I'm not saying an iPhone 8, but I don't know whether an iPhone 8 or does not, but most phones have a little GPU in them. They have that built in. So there is the competitor coming along soon, and we'll see what happens. AMD possibly, or another startup maybe, but we'll see. In the last year and a half to 2 years, it surprised me because normally things go very slow. I mean, we transitioned from a steam engine to a gasoline engine took 60 years. No, it took longer than that, 70 years. And this happened in 2 years. And its profound impact is yet to be seen. It's worrisome a little bit to me. What's going to happen? I just don't, I don't know. So.
Yeah, David?
Oh, yeah, cool. Thanks, Kristelle. Might talk about the individual risk for investors first. As a joke, of course. I think we're a little bit late to start investing in NVIDIA right now. I'm not heading that path necessarily, but you're right, investment advisor. So, I'd leave that to everyone's discretion. So basically, let me try and break down the associated risks with over-reliance on a single chip or technology. And, some of the strategies to sort of, diversify your tech stack and, prevent a bit of that vendor lock-in. And, becoming overly dependent on a single vendor, it limits your options and your bargaining power, right? So essentially what that means is it's monopoly, right? You're not able to sort of make your own decisions based on all the, at least the financial side of it. You get locked in and you're subject to their pricing and their roadmap and their support policies. So that's a problem. Then, technological disruption. So that's another risk. So when you look at that, once you've made that investment and you've gone in with that one vendor, actually, technology is evolving so fast. And when you look at the speed of that evolution, it could be weeks or months, not so much years these days, where, a single innovation can come along and literally completely change the landscape and disrupt your technology investment. And no one in business wants to be there with a white elephant. That's the last thing you want. Right. So the next thing is there's a few lessons learned, I think, during the COVID period, right? So that whole notion of supply chain disruption. So there's obviously a bunch of geopolitical events going on in the world all the time. I don't want to digress into what's going on right now in areas. Then there's, things like natural disasters, pandemics, like I said, COVID. They can actually disrupt the supply chain of technology and specific manufacturers, depending on where they locate their manufacturing operations.
Mm-hmm.
It can actually impact your production or your development environments and literally stall your projects. So, customers need to be able to mitigate these types of risks. And then, of course, there's security vulnerabilities, right? That's another key risk. So you look at investing in one vendor. I don't want to name any specific vendors, but, certain vendors are sometimes a little more prone to vulnerabilities. And when you take a risk on that and deploy most of your technology in one area, obviously, if that vendor has an affliction, it can affect your entire system rather than just being a point problem.
Okay, we really had a lot of learning and a lot of details. Thank you so much, David. Thank you so much, Jack.
Yeah, it's such a great opportunity to have you both here, Jack, David, and also you, Anthony. And there you have it, folks, a deep dive into the AI adoption and in its impact on the cloud. I hope you found today's discussion as enlightening as I did. Stay tuned for more insights and discussions on the latest trends shaping the future of technology. And yeah, don't forget to visit AISC's event. David and Jack will be there as speakers. Until next time, this is Kristelle and you're listening to W.Media Podcast.